This problem says a 1 kg ball at the end of a 2-meter string swings in a vertical plane. At its lowest point, the ball is moving with a speed of 10 meters per second. What is the speed at the top of its path? Okay, so here is the ball swinging on a 2-meter string, and we want to find its speed there. Here the speed is 10 meters per second, and we need to find the speed there. Now we're assuming that gravity and tension are the only two forces acting on it, and tension, by the way, is not doing any work because the object is always moving perpendicular to the tension. Gravity is the only force doing work, and energy is conserved in this problem. So mechanical energy is conserved. Okay. So kinetic energy at the initial point plus gravitational potential energy at the initial point is equal to kinetic energy at the final point plus gravitational potential energy at the final point. Okay, so 1/2 1 kg times 10 meters per second square plus, and for the gravitational potential we'll take this level as the reference. So so initial gravitational potential energy is 0 because y initial is 0, and this is equal to final kinetic energy plus final potential energy. Okay, and this height is 4 meters since this is 2 meters. The radius of the circle is 2 meters. Okay, and by the way, the mass cancels. Okay, so this is 100 by 2, which is 50, is equal to Vf squared by 2 plus Gy final 9.8. Y final is 10 meters. Okay, so Vf square is 100 minus 9.8 times 20. Well, what happened? Okay, we're getting something negative. Okay, let's see. Initial kinetic energy plus initial potential energy equal to final kinetic energy plus final potential energy. The M cancelled. Oh, there is the problem. This is 4 meters. Y final is 4 meters. All right, now that fixes that. That was the problem. So 9 times 8, and so V final works out to 4.65 meters per second. Okay, that's the speed of the ball at the top. What is the tension in the string when the, so part B, what is the tension in the string when the ball is at the bottom and at the top of its path? Okay, so let's do part B. Let's add a page. Okay, at the bottom of the string, the ball is going in a circular path at that speed, and you need a centripetal force in that direction, and the centripetal force is equal to mv squared by r. And the centripetal force must come from tension and the force of gravity. So tension minus mg should be mv squared by r. And so the tension at the bottom is mg plus mv squared by r. Okay, so the tension has to support the weight and also provide, in addition, provide the centripetal force. Okay, so let's calculate the tension equal to m 9.8 meters per second squared plus v squared. At the bottom, the velocity is 10 meters per second, and the radius is 2 meters. Okay, so 1 kg into 9.8 plus 50 meters per second squared. Okay, so 59.8 newtons is the tension at the bottom. And similarly, okay, we'll add another page for the top. At the top, there is V, and this time the force of gravity and tension are acting in the same direction, and them combined provide the centripetal force. So the centripetal force is mv squared by r, and this time it's mg plus tension is equal to the centripetal force, which is equal to that. So now the tension is mv squared by r minus mg. Okay, so last time it was mv squared plus mg, and now it's mv squared minus mg. So at the top, the tension is lower, and this is equal to 1 kg I'll do it like so. M times v squared by r minus g. M times, and v at the top is what was v at the 4.65 meters per second. So at the top, the speed was 4.65 meters per second. Okay, 4.65 divided by 2 meters minus g. Okay, so m times 10.8 minus 9.8, 1 kg, .8 minus 9.8, and that's equal to 1 Newton. So the tension is 1 Newton at the top, and the tension at the bottom was almost 60 newtons. Okay, so the tension at the top is very little, and what that means is this diagram is not to scale. The gravitational force is providing most of the centripetal force. Okay,